Hello, thank you for tuning into this video focusing on data containers in R. As many can attest in the data analytics space, we really are living in the age of big data. And that entails the volume, velocity, and variety of data that's inundated at us on a nearly daily basis. And because of this, a need arises in managing that process. And so the focus of this video will be one particular technique of data management, and that it advocates the storing many similarly structured data frames in R lists while you're interacting with data pieces in your analytics operations. And to illustrate this, I'll be using data from the National Snow and Ice Data Center out of the University of Colorado Boulder, where they maintain NOAA data on Arctic and Antarctica sea ice index. And the good aspect of this data set is that it actually handles many data pieces from a variety of locations. Specifically, on the FTP site, they have monthly data files for both North Hemisphere and South Hemisphere Arctic and Antarctica sea ice index, both sea ice extent and area. And many newcomers to R will probably go the traditional route in tackling this many data set problem. They'll essentially create data frames that correspond to each CSV file. That'll be the first thought process that they'll endeavor. And specifically, this just is you assign explicitly named objects to the corresponding CSV files, and essentially start working from there with each of these data sets. And notice the long-winded aspect to this, repetitive lines going down to the number of data frames, here being 24 for each monthly set for each hemisphere. Altogether, once you finish that step, you essentially have many data sets, frames in your global environment. And this becomes a challenge to work with this in your RAM space during your R session. Another, still on the same traditional route, a few advanced R users will probably import these data sets in a more dynamic fashion, and that's specifically using assign in an iterative loop. Assign is a function in R that allows you to create a variable or object on the fly and assign it a value. And so you're really ultimately doing the same as these explicit lines of really essentially building 24 a sizable number of data frames within your global environment. However, I caution of using this assign aspect. It's essentially because you're really running dynamic operations in a counterintuitive way. You really want to avoid using environment changing methods such as assign, attach, the scoping operator, and still others. These diverge from R's functional programming construct with working with data objects. You want code to explicitly and declaratively assign objects to values and run functions on objects. That's really the core of R's functional programming setup. And then you assign really requires side effects between parents, your global environment. So you still want a different approach to going about managing many data sets. One emerging tool and really is the thesis of this video is really going a different route, and that's namely using a single named list to store many data frames. This avoids flooding your global environment with many separate objects that you have to recall or remember, while you're working. You now serialize data elements for better organization and management, and you avoid a lot of repetitious, tedious code for more readable and maintainable code base. So the adjustment to this is really using the same setup, same paths as the the long-winded assigning to separate objects. Only we're gonna now build a list out of an apply call, specifically sapply. Sapply allows you to build essentially objects from iterables. And what we're going to do is we're going to create a vector of all those prefixes n0 through n12, n1 to n12, s1 to s12, which were the prefixes for the CSV file names in these FTP folders. We'll conditionally, assign, accordingly. The north will go to the north FTP site, and the S will go to the south SPC, the FTP site, and then essentially combine those all together to get a nice list overall. And so instead of having 24 separate objects, we now have one single list, one single global, environment object that maintains 24 different elements. And as you can see, it's really structurally, they're all the same, 42 observations for those corresponding months in that region, be it north or south, January, February, so on, all the way to December. And then same with the S versions. And so we can now take advantage of using this type of structure going forward in our operations. One great aspect of data, using data frames in list is that you now have an indexable reference that doesn't require recall from your environment. You don't need ls, mget, get, eapply just to pull data frames that I need from my operations. You now have it stored, indexed in a larger container. And then a lot of newcomers don't feel comfortable in this new structure because they feel the data frame is limited in some way if it's stored in a list. And that's certainly not the case. You lose no functionality or properties if the data frame is stored within a list. You can still call your same properties, head, tail, summary, and other methods just as is. You're only just referencing it differently. And then now with data frames within lists, you can now standardize operations, especially if they're similarly structured. And so examples of this is showing you can call head with the first 10 rows on the N01 data frame. And notice, I'm referencing a data frame as an object within a larger list here. And so and this is using the dollar reference, operator. I can call a different method on probably the same or even a different data frame. And so this is showing the last 10 rows of the N01 data set. And this time we're using the extract double bracket call, where you pass a character item inside the extract call for to reference that object, here being the N01 data frame. And so on, you can still call as a number. So that's already 3 ways of indexing our objects within a data frame and calling our same data frame methods. And then you can standardize. You can certainly pass your list within looped iterations to run the same consistent operation across all items. And here we're specifically calling summary across all data frames within the CI's DF's named list. And so we can get that output quickly and requiring less lines. We're not calling one, had these been separate objects, in the global environment, we don't have to do mgets or get or even have all those long-winded, laborious, tedious lines that repeat for the similar calls. We can just run in nicely and cleanly using our container of many objects. And so here's showing the describe, distribution across the numerics and integer columns, and then how our characters resolve and emerge. And then plotting also becomes more streamlined. We can now we'll build a grid of 8 rows by 3 columns, because for each of the 24 month data sets, recall we had 12 for each of the north and south regions. Once we pass in our named list object, we just run it through lapply and run our plot selectively for that specific current data frame. Calling plot, where we're gonna run a linear time series trend of extent against year, and then area against year as well. We'll also add another line so we can look at how sea ice extent and area compare to each other across time for those various months. And so we can easily get nice operations streamlined and more efficiently run by keeping our data in a more organized fashion. So here showing the trends across time for those for winter, spring, summer months, and as the literature shows, due to climate factors, we noticeably see that both these trends are lowering across time, as the literature says. And then Antarctica also, shows a slightly different trend, but nonetheless, we do see some noticeable patterns across time. So as you can see, you can really do very sophisticated operations working with many data frames within a larger container, such as a named list. And then compilation, master compilation is easily run. We essentially just pass in our named list into a do call and our bind call, and we can now create a single master data frame that appends, vertically stacks all our data sets to get a data frame of over 1,000 observations, 6 variables, across those numeric character integer types, and then run our data frame like any other. We'll clean the column headers, we'll add a date field, and then we'll order by the date so we can get a nice organization of dates by regions. Showing here the first 6 rows of that data set, and the last 6 rows of that same data set. And then we can export a single data frame altogether. And then finally, now that we have a singular data frame, we can even return back and run a graphing solution showing both Arctic and Antarctica sea ice extent, seeing how they trend across time. Now that we have all our data points together, we can look at the monthly trend. Obviously, have a lot of cyclical activity due to the seasonality of this data, but we can also run a seasonal decomposition to see comparative trends across time. And we see that noticeable decrease, at least in the Arctic, roughly flat with some changes as well seen in Antarctica. So overall, I hope I was able to demonstrate a use case of how working with a list of many data frames really helps the process, helps you organize yourself. Your code is less repetitive, and it's more maintainable and readable, and more streamlined. And so going forward, I hope you can use that into your applications, really in handling all these data sets that come in at us on a daily basis. Thank you so much for your time, and I hope this helps.